Today I would like to discuss how to fit AIRIMA models and time series data. Before going to time series, we'll see what is time series. A time series is nothing but a sequence taken at successive equally spaced points in time. It's nothing but a sequence taken with respect to time. So the time series usually occurs in everywhere. Even we could see that tendency in nature also. It's like the tide of a ocean. So the tide may rise or fall until it reaches the shore with respect to the time. And next in finance, it's nothing but the rise and fall of a share with respect to time. In industrial process, so the waste management, the waste generation can usually occurs with or it is with respect to time. And next in the healthcare, it is the best example is the ECG. So our heartbeat is taken even with respect to the time. These are all the these are all few examples for time series. So like if you want to plot Johnson & Johnson's quarterly earning per share, so it would looks like the increase of the earning with respect to time. Nothing but the increase of earning per share with respect to the time. So what are all the components of this time series are nothing but the first one is the trend. The trend is nothing but the direction of the increase or decrease of the data. And the next component is seasonal variation. It looks like the pattern of change within a year which tends to repeat every year. So like this, the pattern which tends to repeat for every year. And next the cyclic variation. The cyclic variation is similar to seasonal variation, but the rise and fall over periods are longer than the year. So and the next one is the irregular variation. If any time series that fails to follow above 3, then we could refer that as a irregular variation. And next, if the increase or decrease in time series is not in a regular fashion, then we call that series as a random series. These time series are usually of stationary and non-stationary. In stationary time series, the mean is constant. Similarly, the structure of the correlation also is constant with respect to the time. So that is a stationary time series. In contrast is with the non-stationary time series, or it is a non-stationary variation. So here the important issue is how we could fit a regression model such as sort of increase or decrease of data. Usually the regression or the fit is modeled with yi is equals to beta into xi plus epsilon. Here xi is our input data and b is the parameter to be learned or estimated, and epsilon is nothing but the error or noise. So this is the fit model for a ordinary regression. But whereas in time series, what we have discussed earlier is a time series is nothing but a sequence of data with respect to time. So the sequence in the sense the present value at time t means the current time. T means here the current time. The value the value at current time is predicted from the previous data values plus the white noise. Here the white noise is also the white noise also can be predicted with the errors of the previous data, or like, but it is the linear combination of the previous errors. So if we combine this, the regression over the previous data and the regression over the previous error, we could combine, it will give you the AIRIMA, R2 regressive moving average. Usually AIRIMA means R2 regressive integrated moving average. What is that integrated? We will see in next slides. So the value at current time t is predicted with the previous data values plus previous error values. So here phi and theta are the parameters or running parameters. And next, usually the AIRIMA, the seasonal AIRIMA, means seasonal in the sense the trend repeats in every period of time. In the seasonal AIRIMA just can be represented with AIRIMA of P, D, Q. What is this P? P is the order of the autoregressive model, means how many data terms we could add to the current to predict the current value at time t. Means it's nothing but here its yt is not changed. This I have replaced the xt here with yt and wt with the ut. So here it's nothing but the p refers how many data terms we can add. And the next one is the q. Q is nothing but q is the order of moving average model, means how many u terms, and nothing but if you consider the w terms we can add to predict the yt. So p refers to how many data terms and u refers to the how many noise terms we can add. And next, what is here we have to know is about the d. D is nothing but the degree of difference. Degree of difference means if I give a d value means like how many successive differences I can consider. So if only p is given means I could take it as yt minus 1, yt minus 2, or how many terms. If I give the d value means the successive differences. Let us suppose if I give d equal to 1 means at the place of yt minus 1 what I could refer is yt minus 1 minus yt minus 2. Right? The difference, the successive data differences we could consider for the d value. Means d, again we are saying it's a degree of differencing, means such how many differences we could consider that represents the d value. And next, once after fitting, how we could measure the efficiency of the fitted model for AIRIMA is nothing but like as usual as with regression, actual minus the prediction, actual demand minus forecast. So the average of the error gives you the mean forecast error, and the average of the absolute of the error gives you the mean absolute deviation. Mean forecast error measures the model bias here, and whereas the mean absolute deviation gives you the absolute size of the error. So now we are going to see how we could generate an AIRIMA series or a time series for AIRIMA analysis. So this is for simulation actually to say. So how we could simulate or generate mean average means the last part, the white error or the white noise part. How we could simulate that part is like the function in R is AIRIMA dot sim, means simulation, list of order is equals to C of 0, 0, 1. Here C of 0, 0, 1 refers to the P, D and Q value. So here Q equals to 1. So we have only one term for the mean average. So that MA is also given here as 0.9, and how many points we need to generate or simulate with this stand is 100. So just we have substituted here the Q equals to 0. So no data terms is considered as per this simulation is concerned. So there is no X term and only white noise term. That is how we could represent is as we have seen in the previous slides, like Wt plus theta of Wt minus 1. Here that theta is given as 0.9. So Wt plus 0.9 into Wt minus 1. If you plot X once after generation of or simulation of this data, it looks like this. And next, how we could generate the X series or simulate the X series or the data series. So like here as usual we have as discussed in the previous slide, here we have given the p value as 2 and d equals to 0 and q is also equals to 0, means here the x terms are 2. So like how many we have to generate here is xt minus 1 term and xt minus 2 term. So we require 5 values. Here the 5 value for xt minus 1 is 0. So 1 into xt minus 1. So 0 into xt minus 1, it is like 0 plus the 2 is minus 0.9. So minus 0.9 into x, the next term is xt minus 2 plus Wt. So Wt here is white noise we have to add, but the rest of the terms, white noise terms are zeros over here. That's why we don't have any Wt minus 1, t minus 2, right? So if we once after this simulation, if we plot the x, means we could see 2 x terms, two terms, or like this. The plot is like this. So and once as actually, so the AIRIMA.sim is usually for simulating the data for AIRIMA model. In order to fit the once after generation, we have to fit the AIRIMA model. So to fit the AIRIMA model, the corresponding R function is AIRIMA. So you could refer that AIRIMA, complete AIRIMA function from the first site given here. So in this site, the whole prototype for AIRIMA function is given. The AIRIMA function is used for fitting the AIRIMA model on any time series data, whereas AIRIMA.sim is for only simulating the time series data for fitting the AIRIMA model. So here one, the difference factor is 1. It means that when we fit the AIRIMA model, it will take the successive difference. Here means here only 1 we have given. So t minus 1 term we have, that only it will xt minus 1 it will consider. If we given as here 2 means and here 1 means, how it considers xt minus 1 minus or xt minus 2 minus xt minus 1, like the subtraction. So a case study on time series data is given in this blogger. You could if you could follow this blog, you could learn how to fit a AIRIMA model, or how to fit a AIRIMA model on, or the steps you could consider, or the steps that you have to follow to fit the AIRIMA model. You could learn from this blog. So as in your syllabus, ETL approach is also there. As you have read data warehousing in your previous semester, you know what is data warehousing. But here I am just explaining you an ETL approach of ETL, why we use to maintain or to generate a data warehouse. ETL is nothing but extract, transform, extraction, transformation and loading approach. So in order to set up a data warehouse, you have to extract the data from different sources. Usually each source maintains the data in their own format. First we extract the data from sources. As the formats are different from one source to another source, we have to transform that data into a single format. That is nothing but the procedures what you follow to bring the data in one format is nothing but the transformation. Once after you transform the data, you load the data into a final target. It can be a final target, can be a database, or more specifically a operational data store, a data mart, or a data warehouse, or anything you could load. Or it can be, if you consider it as a warehouse, means you could load the data at warehouse. So the popular tools to perform ETL task, or the companies usually use, are like Informatica Power Center, IBM InfoSphere Data Storage, Oracle Data Integrator, and these are all popular. Microsoft SQL Server Integration Service. These are all popular ETL tools to extract, transform, and load the data into a warehouse or a day-to-day database. So some of the slides to explain time series I have taken from this book. Thank you.